Hey guys, Miss O here. Got a question on number 5 from 6.3, and it's all about the transformations on our exponential functions. So first thing we want to do is we want to figure out what graph we're looking at, right? So we're looking at the graph f of x equals 1/2 8 to the power of x. Okay, so one of the fastest ways to figure that out, you can remember that we are looking for a y-intercept of 1/2. And from there, and you can even make a table of values to kind of help you, right? So your y-intercept is going to be at 0, 1/2. And then from there, as you increase, you're multiplying by 8. So 1/2 times 8 is 4. 4 times 8 is 32. 32 times 8 is 256. Okay, so now we know kind of what points we're looking for. So we need a graph that's going to have these points on it, right? So if we started our first one, maybe that's 0, 1/2. It kind of looks high for 1/2, but let's just keep checking, right? So then we should have a point at 1, 4. Well, that's not on the graph, right? So I'm going to go to my next one. So maybe that's 0, 1/2. It's hard to tell. Let's see, my next point should be 1, 4. That looks pretty good. Then I should have a point at 2, 32. So like right there. Okay, so far so good. That one looks pretty good. Okay, but if we wanted to be sure, we could scroll down and kind of check some of our other graphs, right? So if we're checking our other graphs here, let's see here. 1, 0, 1/2. Well, that's not even close. And then here I've got 0, 1/2, but then 1, 4, my graph's not going the right direction. So I know that that second graph that I checked is the right one. All right, so I know I want to use this graph right here. And then I'm going to come down and it says compare the graph f of f to the graph of the parent function. So f, which is the graph that they gave us, let me see here, let me scroll down a little more. F, which is the graph that they gave us, right? They gave us f of x is equal to 1/2 times 8 to the power of x, right? Well, they didn't really tell us the parent function, but we know that the parent function just doesn't have that 1/2. It doesn't have any of the transformations. So our parent function, which we're going to call p of x, is equal to 8 to the power of x. Okay, so I know those are the two graphs I'm comparing. I could sketch them real quick. I could grab Desmos and look at them real quick, or I could know what that 1/2 is doing, right? So that 1/2 is going to do what's called a vertical shrink, okay? And if you look at the two graphs, right? If you look at your two graphs, we've got, let's see here, we've got our parent function, which is going to give us a graph that looks something like this. And then we've got our new function, our transformation, which is that f of x equals 1/2 times 8 to the power of x. And if we graph that, you could use Desmos or whatever. It's going to look very similar. It's just going to be sort of flattened a little bit, right? So whenever you're multiplying by that fraction, it's called a shrink, okay? If you were multiplying by a number greater than 1, you would get a result where your graph is maybe sort of above, and that would be called a stretch. So this would be a stretch, and then our red one here shown would be called a shrink, right? As it kind of flattens towards the x-axis or stretches away from the x-axis. Okay, so we know we have a vertical shrink by a factor of 1/2, right? And of the graph of g of x, which we knew that parent function is just 8 to the power of x. The y-intercept of f, well, we know that that's that a value that we talked about in class today, so that's 1/2. And is below. Whoop. Okay, so this should say below. I couldn't drag it over, my pen didn't work. Below, and the domain of f is going to be all real numbers, and the range is y greater than 0. And that's kind of how you do that one. But again, grab Desmos, use your graphing